Hello friends, we will see today angle properties of circle, also known as arc properties of circle. The very important first property I am going to discuss is angle. You just understand like this: angle made by any arc. You know, this is arc. At the center of circle is double the angle made by the same arc in the remaining part of circle. Hope you are understanding. Angle made by this arc at the center, so this angle is double this angle. In the remaining part of circle, I have seen student getting confused. This is at center, this is at the circumference, and this is double of the. No, it should be in the other part of the circle. What is the meaning of remaining? If we are considering this arc, the angle at the circumference should be at the other part of the arc. It can be like this. Just see, it can be like this. It can be like this. So you can easily say, if this is 30 degree, this will be 60 degree. This is 50 degree, this will be 100 degree. This is 50 degree, this is 100 degree. This is 100 degree, this is 50 degree. This is the double angle relation. Very carefully identify the theorem by means of the diagram. Just one technique I am telling you how to identify. You just see the point. Suppose these points are A, B. Now see, the angle is being made by one line from A and another line from B. So angle is being made by the arc AB. Same way, angle in the remaining part of circle is made by A and B, arc AB. So you can easily identify that this is double of that. This is one theorem. Another theorem you have seen your own in that theorem. Can you tell me which theorem you have seen? You have seen that angles in the same segment of the circle are equal. What is that? Angle made by same arc in the same segment of the circle means it is being made in that segment. So this angle is equal to this angle is equal to this angle. So angle in the same segment of circle are equal. How to identify? Same technique. Starting from same arc and on the circumference of the circle in the opposite segment. So you can identify the angles in the same segment, and angle at the center is double the angle at the remaining part of the circle. Two theorems we have just seen. We will see the application of these two theorems by means of these questions. See, in this question, we need to find A and B. The first and the most important thing while solving such type of problem is see carefully what is given. If we make use of whatever is given, we will find what we have to get easily. See, if we see carefully, what we see? This is center. So we know that OP and OQ are radii. Why? Because they are emanating from center and coming to the circumference of circle. Same way we can say OR is equal to OP. Now if we see carefully, that triangle POR is an isosceles triangle. Why? Because OP is equal to OQ. So very important point, you notice wherever two lines are emanating from center, they are going to be the radii. And if luckily these are forming the two sides of the triangle, then it is definitely an isosceles triangle. Never ignore that property. Okay, that is very basic property, nothing to do with the circle property. So If this angle is 40 degree, this will be 40 degree isosceles triangle. So we can just write A is 40 degree. What reason you will write? You will write that POR is isosceles triangle, and in isosceles triangle the two angles are equal, opposite to the equal sides of the triangle. So this is 40 degree. Now we need to find B. Do you see that angle B is formed by arc QR? Is it? Arc QR is making angle B at the center of the circle. Now we have to see, is that arc making some another angle at the circumference of circle or not? Then we will apply the double relation. We will see carefully that this arc is making an angle of QPR at the remaining part of the circle, and this is 70 degree. So once we know this, we can get this easily, because this is double of that 140 degree. Very carefully you do, and this is going to be the easiest chapter. I am telling you, I am assuring you. Once you understand the properties well, this is very easy. Okay, so you got the application of the theorems here. Now jump to this question. The two things all the time I tell you, what you get and what you have to obtain. Two things very important. So I have to obtain the value of this angle. Yes? See, this angle, that means RSQ, is being made by the arc RQ. Now we have to say that RQ is making an angle at the circumference of the circle. Is it making some angle at the center of circle or not? We have to see. This same arc is making an angle this at the center of the circle. So we can apply the double relation. This has got no relation with this angle, because this angle is being made by arc PR, and this angle is not made by PR. So never hesitate to just see the center and circumference angle and apply the double relation. See which arcs are responsible, who are the parents. Firstly see if the parents are same, then apply the theorem. So this angle is being by arc RQ. So we will see what is being made by the RQ at the center. We can easily get this thing. How? By linear pair. Linear pair, if one angle is something, another angle is 180 degree minus that thing. So if it is 110 degree, this is going to be 70 degree, because 180 minus 110 is 70 degree. Once you know this 70 degree, so this angle and this angle got a double relation. This is 70, so this is, tell me, what is that? This is 35 degree. How easy the things are. See, very easily we are getting the angles just applying the two theorems. Okay, now jump to question number this. We need to find A and B. In this question, we need to find a relationship between A and B that we have to establish. So see carefully, if we just go for a little bit of construction here, and we name this as S. Can you tell that angle A is being made by the arc RP at the center, and same angle is made by the arc PR at the circumference of the circle? So we can get this angle, and this angle we can get, this is the reflex angle, 360 degree minus A. So we can just find reflex POR. Reflex means more than 180 degree. This is A, this is 360 degree minus A. And now see, this angle, reflex angle POR, is being made by the arc RP. Little bit of uneasiness you are feeling in identifying the reflex angle, but see, this angle is made by arc RP. This reflex angle is also made by the arc RP, this arc. So angle made by this arc at the center is 360 minus A, and angle made by this arc at the remaining part of circle is B. So we can write angle B is equal to half the angle made at the center, that is half of 360 degree minus A. So we are getting the relation between A and B very easily. So be careful while finding, just dealing with the reflex angle. This is double of this. Okay, but we have to establish relation with this thing. So we will take care of this angle, nothing to do with this angle. So apply that relation, we will get a relation. Now jump to this very simple question. See, some angles are given and we need to find some angles. So we have to see whatever is given and what we are getting with the given things. You see that this angle is made by arc AC. AC is making an angle of ADC in circle, on the circumference of circle. And see, the same arc is making some angle at the same segment of the circle. Is there any angle? Yes, AC is also making this angle. See, this angle ABC is made by AC. ADC is also made by AC. Again, I am telling you very easy way to identify ADC, starting from A, ending with C. ABC, starting from A, ending with C. So they are equal. If this is 43 degree, this is definitely 43 degree. So we got this angle. What is that? 43 degree. Now, whatever more is given, this is given 49 degree. That means BAC. This angle is made by the arc BC. Is any other angle being made by the arc BC? Yes, if you see carefully, this is angle BDC. So we can write angle BAC is equal to angle BDC. BAC is equal to BDC. If BAC is 49, then BDC is also 49, because angles made in the same segment of the circle by the same arc are equal. Very simple language. So this is 49 degree. Now we need to find angle ACB. No need of applying any circle theorem. This is very common triangle theorem. Sum of all angles of a triangle is 180 degree. You know this, you can find this easily. So you can just write angle A, which is 49 degree, plus angle B, which is 40 degree, plus angle ACB is equal to 180 degree. So if you know the two angles, you can find the third angle. This is little bit of simple application of the two theorems I have discussed. In the next speech, we will see other two theorems, and after that we will apply all the theorems in a combined way, and we will see that problems are very easily solved. For the time being, thank you. Bye bye.